Bunjalaka, the Aboriginal Cultural Centre, as well as IMAX are also located here. The Immigration Museum is located in the old Customs House and showcases stories of people around the world who have migrated to Victoria. And finally, we have ScienceWorks, our most interactive museum primarily catered for kids, both young and old, that presents science and technology as a fun experience. The recently upgraded Melbourne Planetarium is located at ScienceWorks. So Digital Media Systems is a team of just 5 staff, and as you can see, we have a lot of technology to look after. In fact, today there are well over 1,000 devices spread across 386 exhibits that need to switch on and off each day. To do this, we have what is known as a gallery control system. This system does exactly what its name implies. It controls the various devices installed in the galleries like projectors, computers, and even dinosaurs. The role of digital media in exhibitions has grown dramatically over time to the point where it forms an integral part of the visitor experience. It is no longer sufficient to stick a couple of DVD players in the space and hope the audience sit and watch. In fact, since Melbourne Museum opened 14 years ago, the number of exhibits we've had to look after has increased 8-fold. So this slide gives you an idea of the scale of what that means. As you can see, our workload has increased enormously since 2000 with each new gallery install. And they have gotten a whole lot more complex. Our exhibits range from simple looping videos to large-scale installations consisting of multiple computers, displays, and mechanical components. At Museum Victoria, we have long been at the forefront of using digital media in exhibitions. 14 years ago, we invested in a complex and bespoke system that helped us tame our multimedia. Now, as you are well aware, 14 years is a long time in technology, and we found that it no longer served our needs. It was complex, it wouldn't work with new technology, we still have Windows NT workstations, and the company that developed it went bust, so we had no avenue for support or changes. When we scanned the market, we knew exactly what we wanted, but we couldn't find anything that would do the job just the way we liked. We were also very cautious of again being locked into a proprietary product that we had no control over. During the search, we realized that museums have unique requirements for delivering their digital media. They often consist of a large array of devices that operate independently, but need to be managed from a central location. Other solutions we looked at were more device-specific and would often rely on proprietary and expensive hardware for control. As Nodel is pure software, it can be written for more general device control as required. Our idea of a control system was something that would be reliable, modular, and adaptable to our present and future needs. It had to be developed using widely recognized programming languages and coding techniques that would be well documented, so lots of programmers, maybe some of you in this audience, could develop code for it. We found a partner in Lumicom, a Melbourne-based software development company with extensive experience in AV integration. 2 of their software engineers helped us design the system architecture and coded the platform. So we took this idea and a business plan to management, and they took the bold step of supporting us and investing in this project. So after 2 years of planning and development, it was actually about 8 years of talking about something like this, we had a brand new control system that was launched as part of our First People's exhibition at Melbourne Museum in September last year. So what is Nodel? The name Nodel was chosen because it describes a system architecture, which is simply a whole lot of nodes on a network that talk to each other. This system is made up of 2 parts, the platform and recipes. The platform or core system is the communications layer that enables interactions between different nodes and is written in Java. It uses common and open protocols like MDNS and ZeroConf to establish communication on the network. Messages between nodes are formatted in plain text using JSON, which is highly efficient and minimizes network load. Because JSON is human readable, communications can be easily examined during testing and troubleshooting. The recipes are scripted in Python and tell nodes how to function. They can be written to perform specific tasks like controlling devices or querying the status of nodes. Nodes have relationships and are non-hierarchical and talk to each other using a series of actions and signals. Actions are one-to-one and tell other nodes or devices what to do. Signals are one-to-many, and nodes can be scripted to listen out to other nodes and then perform actions. The way Nodel is implemented is a natural way of thinking about control. And the developers tell me that Nodel has taken out a lot of complication of implementing the natural way of doing things. So thinking about actions and signals is kind of common sense, but actually implementing the software is quite difficult, I've been told. Nodel has a simple and elegant design, both in its visual interface, as you can see here, as well as the underlying system architecture that uses industry-standard open protocols like Java, Python, and JSON. So what does it do? Nodel is a framework that locates, establishes, and maintains a connection between nodes. It ensures this communication is valid and error-free. So users don't need to worry about network environment and how devices talk to each other, but just what they need to do, sequencing. Nodel takes care of the communications and challenges often faced with different network environments. In the world of Nodel, scale doesn't matter. The protocol has been designed to handle hundreds of thousands of nodes reliably without putting any strain on the network. You can add, remove, and relocate nodes live without affecting the rest of the system. Nodel will automatically re-establish communication using the bindings when they need to communicate. So how is it better? Because Nodel is written in Java and Python, it is platform independent, and nodes can be hosted on any operating system that supports the Java runtime environment. Its system design makes it very resilient to network interruptions by using its underlying network discovery protocol to locate and then perform the tricky task of reconnecting mass amounts of nodes in an orderly manner. Nodel has a responsive web interface and can be accessed from any device with a browser and is made for mobile. And we have chosen to share it with the world. Anyone can use it and make changes to Nodel as long as these changes are contributed back into the project. Yes, Nodel is open source and free. The code and recipes are available on GitHub under the Mozilla and MIT licenses. And that's the URL that tells you everything about it. So far we have developed recipes to control a wide range of devices we use in our galleries, such as computers, projectors, power devices, TCP, and I/O. So I'll just give you a short video that demonstrates how easy it is to create a node. So all you do is, once the Nodel service is running, is create a new folder, and you just type in the name of the node. That's me typing with 2 fingers. And as Nodel is running, the script automatically appears right there. So if we have a look at that example script, it gives you an example of how you can script nodes. It's quite simple if you know Python. So this is all in Python right now. And this is the bindings file, which connects all the nodes together. So right now it's just empty. You don't need to actually do anything right here, but I just thought I'd show you what it does, or what it looks like. So here's one we prepared earlier. Drag and drop. And it looks highly complex, but you can see it's pretty much just sequencing different actions that the node needs to take. And there's some events down below. And all this is just copy, paste, change the name. So if we go to the page, the URL of that node, you can see there's an inline script editor. So it's got the same script. So you could be on your tablet and start creating nodes. You don't need a text editor. So that's just the same thing that I showed you earlier. Okay, so the new node appears on the web page, and I'm just going to start creating some signals, and you can see it's all auto, what do you call it? Auto fill. So it recognizes other nodes in the network. It knows what the node name is called and what the actions or the signals that node is emitting. And for actions, it's the same thing. Once again, it recognizes nodes that are on the network. So you just select the node that you want. Put in the action. And just in case you missed out, I did another one, I think. No, save. Boom. And that's it. Done. So you can see there's a console that tells you that the script is running. If there's any errors, it appears on there. And so it'll be in red. And then you can fix up the script if you need to. So this is the bindings file that I showed you earlier that was empty. It gets populated because I've gone ahead and filled all the actions that node requires and the signals as well. And this is really handy when you've got different exhibits that do the same thing. All you do is copy, paste, and just rename the names. So this you don't really need to use this file when creating nodes, but it's handy to replicate. And just to show you, all those bindings appear on that node on the web page. So obviously for development purposes, it's easy to have a computer and start doing all your work. But if you're on, like we use a tablet when we go around galleries, and if you find there's issues or we need to change anything, we can just do this on the fly. We can even do it using this with the new 6 Plus. And that's it. So these are all the nodes in our First Peoples gallery. Simple as that. So a lot of them are